Encapsulation method. The choice of most suitable method, it depends upon the type of core and application for the microcapsules, the size of the particle required, the physical and chemical properties of the core wall, the release mechanism it required, the production scale and cost. In this micro encapsulation method, there have spray drying, spray cooling, extrusion, conservation, and lyophilization, and final one is emulsification. These are the methods which are included in the micro encapsulation process. First of all, we are discussed about spray drying. In this process, the formation of emulsion is happened. A solution or any suspension containing the core and the material that followed by the nubulation. In drying chamber with the circulating hot air, the water evaporates instantly in contact with the hot air. The material encapsulate the core. Atomization has some advantages over these methods. Large requirement availability, possibility of employing wide variety of encapsulating agents, and large scale production will be occurred, and it is a simple equipment. It means here only drying process will be performed. It contains good efficiency, and storage will be reduced. The transportation cost and process cost will be lower compared to the other processes. The main disadvantage of this spray drying process, the production of non-uniformly sized materials will be occurred. In this spray drying technique, the most common microencapsulation method has been used for decades. This is mostly used process, so that's why to encapsulate mainly flavors, liquids, pigments, but its use in thermosensitive products such as microorganisms, essential oils can be limited because the required high temperature causes volatilization and destruction of the process. So thermosensitive liquids are not required are not suitable for the spray drying process. Otherwise, the liquids, semi-solids, solids are mostly used in this process. Okay. Next method of microencapsulation is spray cooling. After spray drying, the spray cooling process will be occurred. In this spray cooling process, it is based on the injection of cold air to the solidification of the particle. The microparticles are produced from a mixture which containing the core and wall materials in the droplets. The mixture is nebulized by an atomizer and that enters into the chamber which the air flows at low temperature. The temperature reduced, it results the solidification of the wall material. Okay, and in this spray cooling process, the microencapsulation is considered the cheapest encapsulation technology by employing lower temperatures and with high potential for the scale up process. However, microparticles are present some disadvantages which includes low encapsulation capacity and expulsion of the core during storage process, and in this spray cooling we can use it to encapsulate mainly minerals and vitamins. Okay, after that, extrusion. In this method is based on the polysaccharide gel and that immobilize the core when it contact with the multivalent ion. The extrusion involves incorporation. The extrusion involves in the incorporating the core in sodium alginate solution. That core will be extruded into the mixture by undergoing dropwise extrusion via a reduced caliber pipette or any syringe into the hardening solution. Nothing but that solution is taken as calcium chloride. In this extrusion method, first we have to take a calcium chloride solution which is used as a solvent, and then the core will be incorporated into the sodium alginate solution, and then in that solution we have to inject the calcium chloride as a dropwise. The main advantage of this extrusion process is it is a very long shelf life process, and it is very long shelf life microencapsulation method, and it is mostly used method in this large scale of industries. And one small drawback is of this technology is large particles are formed by the extrusion, so that's why the limit that use applications are mouthfeel is crucial factor. In addition to that, very limited range of the materials are available in the extrusion encapsulation method, so that's why it is might avoided in the laboratories, but this process will continued in the industries. Okay. And then coacervation is the technique which involves the deposition of the polymer around the core by altering the physiochemical properties of the medium. At such temperature, the ionic strength, pH, polarity, this will be constant. Then the deposition of polymer will be happens. It is a simple coacervation process, and when there are two or more molecules of opposite charges is referred to as a complex coacervation. That time this process will be complicated. The coacervation is a relatively simple low cost process, and it does not require any high temperatures or any organic solvents. It is typically used to encapsulate the flavor oils. And one of the main disadvantages of the coacervation process is we have to put that occur only within limited ranges of the pH and colloid concentrations and other electrolyte concentrations. That is the main drawback of the coacervation process. And the next process is lyophilization. In this lyophilization process, the dehydration of frozen materials under a vacuum sublimation process will be occurred without submitting the sample to the high temperatures. Without submitting the sample to the high temperatures, the dehydration of the frozen material will be occurred under the vacuum sublimation process. The whole process is known as lyophilization. In this method, the excellent quality products will be formed, because it minimizes the changes which associated with the high temperature, and it is widely used process of enhances, essences and flavorings. In large scale of industries, the essences and flavoring production process, this lyophilization process will be used. However, it is high cost and long process. It takes more time, and it also commercially applicable. Last micro encapsulation method is emulsification. In this emulsification, the core is dispersed in a organic solvent where the wall material is dispersed in the emulsified water. The organic solvent is removed by the evaporation under stirring process. The polymer globules are formed after the core is encapsulated. In this technique, we have been frequently used the simplicity of the procedures which involved the producing particles and components of the formulation and preparation conditions. In this emulsification process, it is used to encapsulate mainly enzymes, minerals, vitamins, microorganisms. With the use of encapsulation enzymes, the emulsification process is mainly used in the cheese production and the increased rate of proteolytes compared with the free enzyme production.